All right, so how are we going to start this problem? This is a riveting beginning to a video. So I'll read the question, and then I'll ask for someone to help me out here. So the skull accounts for 15% of the weight of a T-Rex's bones. A T-Rex's bones account for 21% of its total weight. What is the total weight of a T-Rex whose skull weighs 570 pounds? That is a really heavy head. Really big. All right, so let me ask you this. What are we going to have to figure out in order to solve this problem? Grayson?
The total weight of the T-Rex.
Okay, so we need to find the weight of the T-Rex. Now, in order to find the weight of the T-Rex, what do we need to figure out first? What will we need to figure out aside from the total?
The total weight of the bones.
We need to figure out the weight of the bones. And then what are we going to use to find the weight of the bones?
The weight of the skull.
Weight of the skull.
Weight of the skull.
All right. So we have a little roadmap here. So how are we going to figure out the weight of the bones if we know the skull is 570 pounds?
Well, we know that the skull is 15% of the bones.
Okay.
So we could make like a ratio, but.
All right. So 15% is 570, and so we're trying to get to 100%. Okay. So how are we going to solve that?
Multiply by 115ths.
Multiply by 115ths. I think there might be an easier way. Well, actually, that's probably a quick way. But does anyone other than Grayson know what I should type into my calculator?
Can you do?
Hey, Alex.
Alex Prusner? Okay, so you sound like you're a stormtrooper in Star Wars. It's actually kind of cool. So you said you're going to figure out how many times 15 goes into 100.
Yeah.
And so you're going to multiply that. All right, so multiply that by 570. All right. So what does 3,800 represent in the context of this problem?
The weight of the bone.
This is the weight of the bones, okay. Now, Grayson, did you have a faster way of doing this? I think you were hinting at that.
Gavin is his hand up.
Gavin?
So I multiplied 570 by 2 because when I multiply 15 by 2, I get 30. So then I'd have 30%. And then I divided 30% by 3.
So you get 10%.
And then I multiplied 10% by 10.
That would get you the same answer, wouldn't it? Okay, cool. All right, so now that we know that we have 3,800 pounds of bones, the amount, the weights here are staggering. So now what is the next step?
Avery.
Avery.
Next we would do 100 divided by 21 to get what we would multiply the total weight of the bones by, and that is equal to I think 4.761. So, and then if we multiply that times 3,800, we get 18,095.23. And since we have to round to the nearest whole number, we would just have 18,095.
So how, and what did you round it to? Oh my goodness.
$18,095.
All right. All right. So this was obviously a question about ratios. Today we're going to talk more about systems of equations, really writing equations to solve problems. And so I'm going to provide a little bit of not necessarily homework, but homework to get ready for Thursday. Now Thursday we will have a competition. You buy 3 candy bars and 5 lollipops, and it costs $3.70. While your friend buys 4 candy bars and 2 lollipops. Now, obviously, you guys don't really pay a whole lot of attention to how much each candy bar is and how much each lollipop is. So once you're done buying your stuff, a third friend joins you and wants to buy a candy bar and a lollipop from you. Now we need to figure out how much each candy bar and how much each lollipop is so that we know how much your friend is going to owe you. So how are we going to do this? Any ideas?
We could do a system of equations.
Okay, and a system of equations, again, is we're going to write 2 different equations and solve them, and we'll be able to figure out how much each one of them is. Okay, so I'm going to give you... Go for it.
Is it given that your friend also spent $3.70?
Oh, shoot. That would be important information now, wouldn't it? So your friend spent $3.30. Where is that dollar sign? All right, so I'm going to give you a couple, I'll give someone was able to come up with.
Caroline.
Caroline?
4C plus 2L equals 330 when C is candy bar and L is lollipop.
All right, and how much does that equal to again?
$3.30.
Okay, and how did you get this equation? Just so in case others were struggling with this, how did you put this together?
So it said, while your friend buys 4 candy bars and 2 lollipops for $3.30, so 4 is the same as equals 2 in terms of turning it into math equations, and then 4 candy bars and 2 lollipops. So I abbreviated candy bars into C and lollipops into L, and when you bought 4 candy bars and 2 lollipops, it was equal to $3.30. So I knew that you would have to add 4C plus 2L.
Okay, that makes total sense. All right, did anyone come up with another equation for the first part of this?
Grayson.
Grayson.
3C plus 5L equals 3.7.
And how did you get that equation?
Well, because 3 candy bars plus 5 lollipops, that costs $3.70.
Okay, that makes sense. Now we are going to use the elimination method of solving this, also known as the multiplication addition method or the combination method, but elimination makes more sense. What we want to do is we want to eliminate one of the variables by multiplying one or both equations by a number to create opposites. So I don't particularly care what we try to eliminate, either candy bars, C, or L for lollipops. Luke, which one would you like to eliminate? What do you like less, candy bars or lollipops?
I don't know if there's much controversy about this, but probably I don't like candy bars as much.
Okay, so we will eliminate the candy bars. So for you candy bar aficionados, we're sorry. All right, so we want to multiply, in this case, both of these equations, because is there a number that I can multiply either 4 or 3 by that's going to create the opposite without having to multiply things by fractions? Say no.
No.
Thank you. It took a while to compute. So in other words, we're going to have to multiply both equations by something. So opposites mean, we're talking about negative and positive. So what can we multiply this top equation by that's going to help us create the opposite C's? Any takers on this one?
No.
How about Claire?
Well, when I did this, I eliminated the L's, but you could multiply the top one by 3 and the bottom one by 4 to cancel out because they both equal 12.
So when I multiply the top equation by 3, I'll get 12C. When I multiply the bottom equation by 4, I'll get 12C. Now, just for good measure, I'm going to multiply the bottom equation by -4 so that I do create opposites. So I get 12C and -12C. So what is 3 times 4C? 12C. What is 3 times 2L?
6L.
What is 3 times 330?
9.9. 990.
All right. So what is -4 times 3C?
Negative 12C.
What is -4 times 5L?
Negative 20L.
What is -4 times 3.7?
Negative 14.8.
15. Negative 1480.
Can I get someone to confirm the -1480? Because it sounded like something.
Yeah.
Okay. So now, if I were to add these two equations together, let's see what happens. What is 12C minus 12C?
0.
0. It cancels out. Okay. What is 6L minus 20L?
Negative 14L.
What is 9.9 minus 14.8? Calculators are fine right now.
Negative 4.9.
Okay, so now what do I do next?
Divide negative 4.9 by -4.
Okay. And what do we get?
35.
What?
35 cents.
35 cents?
Yeah.
And that sounds somewhat reasonable for a smaller lollipop. I mean, 3 for $1. It's not too bad. Okay, so I know how much a lollipop costs. How will I figure out how much a candy bar costs?
Well,
Plug that in.
5
Okay.
in for all equations.
Does it matter if I use the top equation or the bottom equation?
No.
Nope. So let's use the top. Let's use the top. So we have 4C plus 2, and what's our L value?
0.35.
And we know that that is going to equal 3.30. Okay. So now what?
We can multiply 2 by 35 cents.
Okay, and 2 times 35 cents is in fact 70
70
cents. So we have 4C plus 70 is equal to 330. All right. So now what? That's 70 cents. Almost.
We can subtract 70 cents from both sides.
All right. Now, everyone should feel free to jump in there, not just manual or Grayson manual all the time. Although Grayson, you're welcome to keep doing it if no one else will. So we have 4C is equal to, what's 330 minus 70 cents?
Hey, Mr. Frankie.
Hey, how's it going, Tate?
I'm good. How are you?
So we're talking about systems of equations again. And that's 60, right? So now what do we need to do to both sides to figure out the value of a candy bar?
Divide by 4.
Divide by 4. And so we get a candy bar is equal to,
65 cents.
I could almost understand that. One more time.
65 cents.
65 cents. So are we done?
Nope. Nope, you have to add the candy bar plus a lollipop to find what your friend owes you.
Okay, and how much does your friend owe you?
$1. $1.
$1. All right. So being the nice friend, they're going to pay you back $1. All right. Are there questions on this problem? Okay. So this is my personal favorite. So Walter and Avery are going for a run. Walter stops to tie, misspelled in this case, his shoe for 2 minutes. The rabbit had a hard time going into the hole, with the bunny ears and everything. Anyways. All right. Is anyone even acknowledging it?
Carolyn's cracking up.
Okay. All right. And then Walter runs fast to catch up with Avery. If Avery runs at 7 miles per hour, not too shabby, sir. And Walter runs at 9 miles per hour. Very nice. That's 6 minute 40.
Mr. Frankie, why wasn't I ahead of Avery in the first place? Because you're slow, Walter.
Because you're chit-chatting. How long will it take Walter to catch Avery? All right, so let's talk our way through this one.